In this episode of Finnugric Machining, we are making a lot of gears. Well, I already have made a lot of gears, actually 3 of them, and I failed. This is a little bit strange gear. It has, first of all, I will put a picture there. It has a hole which should be exactly on the center, of course, and then it has an eccentric part. It should be quite exactly round, of course, and the throw should be quite exact. And now, when I made these were originally in a row like this, in one piece of thing, and then I just made the gears and the eccentrics, and then I cut them. And after that, I had a problem with the center hole. There was nothing I could reliably dial this. so the holes went which direction. Well, the deviation was not much. Something like, it's quite a lot actually, 0.1 millimeters at the maximum. And then I made another mistake here. This should be 15.9 millimeters, the eccentric diameter, and now it's a little bit less than 50. And this all makes me, well, of course, feel bad, but I'm not the guy who gives up. So, I will make it again. This time I'm not going to put these into one piece of cutting one by one. I will make an arbor for this. That's the solution here. There is one thing that is specific about this eccentric part and the gear. The gear tooth must be in sync with this eccentric part, so that all 3 are completely identical. Now they are not. So this will cause later on, what I'm doing with those will cause a lot of trouble. So let's start with cutting the blanks for these, and these are, it's just an easy operation, parting off and etc. But stop talking and start doing. What you are looking at is 25 millimeter in diameter cold rolled steel, mild steel. I will cut suitable pieces out of this. First, I just face it, cut it, face it, cut it. 3 couples of them. planks are ready here. So what I will do next, this was the side that I faced. I will do nothing for that one. This time I will now put this into here. Remember, this was, I tried to orient this in the same way, but it doesn't matter in this case really. Just trying to wiggle it so that it, now it's as straight as it can be. And now we have a horrific nibble there. I don't want to destroy my tool with this one. I fly it away. Actually, this goes faster than making it with this one, because you need to take baby steps with that one. So now let's touch that a little bit, lock the carriage here, and then we go. That's the first phasing operation. Of course, with safety glasses, which I always, I always forget them. And I'm running this quite fast. It's, well, 800 revolutions per minute, not per second. Then let's take a little bit more, and there we go. So now the next operation will be to drill. Well, drill and ream an exact 10 millimeter hole through them. Starting with my stub drill, and we need that, and then we need a little bit less speed. Not that much. I believe that's our speed. Yeah. Yeah. And then this is the starting hole now. And it doesn't hold the hole. So now it goes. The next will be 9.5 millimeter drill, and this will be drilled all the way through. Let's see now that. Well, this is 9.75 millimeter pre-reaming drill, and yes, it was 9.5. This one you prepare the hole for reaming. And this needs a little bit more juice. So 9.75 millimeters this time. this one has to be put quite far away through. This has about 10 millimeters taper at the start. You can see it goes into there. But yeah, and this needs a liberate amount of cutting oil. Hopefully our speed is this black a little bit. There you go. We have these three blanks ready. Okay, so far so good. We have holes that are quite accurate, 10 millimeter holes. The hole itself is straight, but there is no guarantee that it is direct. There can be whipslash whatever kind, because I used drills to make these holes. So therefore, we need an arbor. Actually that hole will be our reference here. So for that arbor I'm using this. This is chromoly, and well, I will cut it in half because we are going to need two arbors. One that is eccentric and one that is concentric. Yeah. Cut in half, chromoly, no trouble at all. I thought that this might cause us a lot of trouble, but no, it was actually quite easy. Okay, after fiddling a lot with these sims, I finally got it exactly to 2.54 millimeters throw. So, I have already faced it, and now the next operation is to turn this down to 10 millimeters, and it should be quite exactly 10 millimeters. have now 0.3 millimeters to go to 10 millimeters here. And I have changed the insert here. This is now with a very small radius, and it's super sharp, and it produces well, very good surface finish. It's not a very good insert for roughing because it doesn't break the chips, but for this job it's really nice. I am now going to peel off this rest in 0.1 millimeter cuts. So here comes my first cut to peel off. And yeah, of course, I have slowed down the speed to 300ths of a millimeter per cut. And yeah, the speed of speed is 800 revolutions per minute at the moment. Okay. Well, the surface finish doesn't leave, let's say it leaves very little to wish for. So, well, as I said, maybe you can see this, we have a tenth of a millimeter to go. Yeah. Let's see, I think we have some taper here, or do we? No, we don't. Oh yeah, 100ths of a millimeter taper, well, yeah, okay. So, 1/10. By the way, I locked the carriage, switch off the feed, and then I release the compound. I will now face this backside, and I will feed with compound just a little bit here. Then I will come back like this. That should be ready to go. Wow. Let's try with one of these. Be very careful, it might go. So, no. This is really nice. It's exactly. Good. So, here is now the threading operation with the dye. So I have added Liberately, this lubricant there. And then, yeah, this is just, well, this is in back gear, so, okay, and I'm supporting it with the tailstock quill, so that it goes straight. And this is chromoly, and yeah, I can tell it is. This is really like, really unfriendly thing to trade. But we don't need much here, so I think we already should be there. No, we are not. A little bit more is needed. I think now it goes straight whatever I do, so I can take these away, so it's easier for me. I have more room here to operate this. This requires some strength. Doesn't want to go voluntarily into the And it's really stiff also to remove. I believe it's a little bit more. This was really amazing. Well, it's chrome only. A little bit more. Okay, that's enough. Well, now that I have made this eccentric arbor, it goes to this collet like this, and I can tighten it there, and I can when I now turn this will become eccentric. Yeah, there will be a knot, and unfortunately that knot is sacrificial. It will be destroyed in the process. The next thing here is to create a similar thing, but this time straight. So I made it here. Make it here directly. Okay, just noticed when I'm looking, here is a looking glass for the oil, and it's well, it's almost empty, so we need to add some more here. And in this lathe you just unscrew two very small, these are M3 screws here. They hold a cover plate like that, which should be really clean. Let's see, I want to clean this environment thoroughly. Okay, it is. And then just fill in the oil into there directly. It's, well, I have here some, it's, well, just oil. Gearbox oil, I believe. And then I look into the glass. It doesn't need much, but nevertheless it needs some. A little bit more. Okay, and then a drop into this small thing. It will lubricate this thing. There is a well, a bearing surface which needs to be lubricated every now and then. And this is the occasion when you do it. And then you put this back. And not drop the screws there. That would be disastrous. Well, they go there and you really need to get them out from there. And that would be next to impossible without taking apart the whole thing. So, very careful with these. So they go where they should be. And these don't need to be really tight, just so that they are there. And there you are. When I measured this here, yeah, so I noticed this is now well 10.4 millimeters quite exactly, this one. And when I measure it here, it is 10.35 millimeters, quite exactly. So we have a 5/100th of a taper, and that's too much for my taste. So what I will do now, I will, the carriage is now locked, and I will feed with the compound here. So if my compound is properly set, it should eliminate that taper. Compound straightening operation. Well, first of all, we have here the compound is not straight because we got taper into this workpiece. So now, well, first of all, the setup. If I would measure it from the tool side, from the front side, I would get no needle movement at all. Pointless. Yeah, really. But when I measure it from the back side, I will get double the movement. So when I move it like this, from to there around, I am getting about 0.1 millimeter deviation there. Oh yeah. Okay. Let's move this a little bit so. The aim here is to get the same movement here, but only half of that. Then the compound is straight and we only measure the taper. So I loosen this compound from the back side here. Well, yeah, okay, a little bit more actually. It moves so easily that you have to be really careful with this one. Let's see now where we are. Well, almost no. Well, we need to move it a little bit more. Yeah, it moves. But let's see now. We are approaching. Well, actually, I think we are there. So now I tighten this and recheck that we really have, so that it doesn't. Did it move? I didn't see. Well, now the compound is tight. Let's recheck. Well, the thing here is the difference, not the absolute values. And this is now probably all right. Okay, and now I actually start with 5/100ths of a millimeter at this end, and then it should become straight. So let's speed it up. Now let's measure that one. This will be exciting. Well, here we have 10.11. And here we have 10.11. Yeah, that is how you straighten your taper when you are feeding with compound in one go. Let's go. This is now the final pass. There you are. Yeah, it's wonderful. Let's measure it just for the sake of it. So this side should be quite exactly 10. Well, it's 1/100th of a millimeter undersize. And this one, well, there is 1/100th of a millimeter taper here. But it's 1/10 of what it was originally. And there you are, I believe. Now we have the arbor here. And and this is the first workpiece we are going to process here. I just put it there, then I have a washer like that, and then I have a nut. And that's it. Well, I don't know how tight, but I believe that's tight enough. So our first task is to peel off 2 millimeters off from this surface. The gear outer diameter will be 23 millimeters and this is 25 millimeters stock. So it should be quite that much, so I'll start doing that. Well, that was really convenient. So now the next step, I have now 3 pieces of these which are all 23 millimeters, quite exactly 23 millimeters in diameter. And next step, because I'm going to make a gear on one of these ends. So I wouldn't like to make the gear teeth all the way long, so I relieve some of this material. I put it the other way around because I'm going to, this way I get rid of this horrific burr on the other side. I will do the same thing with the others. And there you are. Well, that was quite amazing, really easy. Arbors make your task looks like really easy. Well, yeah. Wow. Now we have 3 of these. Next step will be the milling machine. Well, now, since we now have these three neat gear teeth, so this is the arbor from the lathe. I will be using it here as well. So I measured like how far should I put it there, and it's about that much, so that I have room to navigate with this gear cutter. So now I just dial this into this chuck, and well, lucky me, this only needs to be done once. This is namely not a very nice chuck to. It's within 100ths of a millimeter now, and that's well, I would say more than good enough for us. And then I just put our first patient there, and it doesn't, of course, because it's at the moment it's symmetric, so it doesn't matter if it's orientation it's sitting there. And then tighten this, and then we should align the blade. I have here a piece of metal which is supposedly straight. Brake on. So let's see that this is clean, because it must be clean this time. Okay, I put it on top of here, so I can see right away. Let's see now, I put it on the edge so that I can feel this edge here. Now it's a very good thing that it is sharp, because you feel it easier. Okay, up a little bit more up, more up. Oh, now we are there. Let's lower the table. Okay, still. Put 200 more. Yeah, there you are. Now the top of this blade is level with the top of the workpiece. So this is 4 millimeters thick. So how much should I raise the table? So 23 divided by 2, 11.5. Minus, now minus 2 millimeters, so it should be 9.5 millimeters up, right? Yeah, 9.5 millimeters. So 1.5, 3, 4.5, 6, 7.5, 9.5. So now it should be on the center height. Just visually checking that it is. It is. So that's now aligned. Next, I will put this in 3, so I can rotate it, so then I can adjust this so that we touch it. Okay, before I do anything else, I would like to put this in a 0, because now I need to lock this. And when you use a dividing head like this, it's a very good idea to start from a 0 position, in case you need to retrace your gear. Well, this has happened me many times. And then as you can hear and see, there is a lot of backslash. I will take the backslash away manually every time when I do this. Okay, now it's locked on the first position of this gear. So, let's see now. So, I was trying to touch here. It's easier to do this way than by rotating. Okay, now it touches. Little bit back. You can feel it easier than you can hear it, because this is quite silent. Now, there you are. And then I zero this dial. And now, the depth of cut. Well, the depth of cut in this case is, because it's module 1 gear, the addendum, the upper part of the gear tooth, is 1 millimeter. Dedendum, the lower part of the tooth, is also 1 millimeter. So that makes 2 already. And then we have, there is this relief, and it's 0.25 millimeters. So 2 by 0.25 millimeters this time. Quite easy. So what I will not do yet is to adjust that, because I actually took it a little bit back. I need to adjust the automatic. Let's see now where I dare to go here. So that's our place. And I will set up the auto stop here. This needs to be stopped automatically, and this is quite easy. You just put the gear on and then you slide this until you can hear the click inside there. It's a very faint click, but you can hear it. And just when it clicks, there you are. Now it stops quite exactly at that place. And I had some spare to go there, yes. And the center line of this is past. Well, it's not past. So we need to go a little bit more. This is really not easy to determine. Well, maybe I shall go as far as I dare. Well, that's as far as I dare. And then I readjust this again. There was my click. And now it's it will stop right there. Okay, and then the next thing is to check. Okay, now I could set the depth of cut. So actually that was our touch position. Yes, I can feel it is there. So now 2.25 millimeters. So that's 1, that's 2, 2.25 is there. Yeah, lock this. Why is locked? We don't need to move it anymore. And then what I also like to do here, so that I don't need to think about this movement here, is to put it in a place where I can safely, will it cut this on the, no, it shouldn't. I think that's a good safe place for me. When I back it up from after the teeth is cut, I go somewhere and I usually put, this is a dial, which I then put to 10. So then I know that when I back this up to 10, here, then I know that it's safe to rotate the dividing head. Okay. So far so good. So now, well, I already did those three gears that failed. So therefore, I have here everything ready. So it will be 21 teeth in this gear. So this means that, well, I have a disc with 21 holes in it. I will be using that. So it means that we have to have 40 holes for each teeth. So because it's 21, it's one hole turn and then one turn which is less 2. So 19 plus 21, that's 40. Okay. And now I think I can put my gear on. And then the speed of this, let's turn the milling machine on. The speed should be something like, I think that's a little bit, let's see. No, it's too slow. That's about right. Okay, so it became 100 revolutions per minute. And then seems like I already have the feeding correct. It's 20 millimeters per minute. So it takes about 30 seconds to mill one teeth and then come back and everything it's really horrific. So we are almost ready to start. So now this is Rockall paste. And I have my glove here. Well, I don't, in this case, I don't use the, You can straighten the fingers that way. So I'm not using the liquid Rockall because, well, because it's, in this case it's not very nice. This is easier to use. You just, this is like butter. So you just spread it around there and it takes care of the lubrication. This is cutting paste. There you are. And this is horrific stuff in a way. Wow. Oh yeah. Now we are ready to go. Yeah, I think I made it. I nailed it. No mistakes. Okay, so 63 times with no mistakes. Yeah, that's an achievement. I have put the eccentric arbor here in the collet sack now. It's fully tightened there, etc. Then what I have done here, I have drawn a line here. And then what I do, I will put my liner here, and then I align this line so that it there. These teeth must be in sync with the eccentricity. So therefore this is important. And then I just put my gear there, maybe the washer, and the nut, which actually will be destroyed in this process. And then what I do, I will bring this near. I will wiggle this a little bit, this gear, so that this tool goes into the bottom of there. I'm not tightening this just until the wiggling stops. I think there you are. Well, it wiggles some. Now it's fully stopped. Then I tighten this and really hope that I don't destroy my tool here in the process. Okay, let's pull it out. What I would like to see now, whether it turns. The washer is important here. It shouldn't turn now with this, but you never know. I can see very soon if it does. No, it doesn't. Okay, there you are. Well, yeah, this nut will be destroyed when I turn this eccentric part. And now we have the gear set in a certain way here. And each of these three should be set in the same certain way. Okay. And now the next step is just to turn the eccentric. Yeah, there you are. Oh yeah. Now it's okay. And let's see the other side. Oh well, 5 microns under in the middle then. Yeah, this is acceptable now. Okay, and now the nut. Let's see if I can manage with these. Oh, we have a flat spot here. Oh, that's nice. Yeah. Well, there's your nut. Oh, well, maybe it could be used somewhere. But my washer has also suffered something. Oh man. But this is now perfect. Yeah. And maybe a little bit deboring here. Somewhat, but not much. So now I have everything here. When I put the next one in, it will become identical with this one. So, I got it, well, much better this time. These three have, first of all, the bearing surface, this eccentric part. Well, they are all within 1/100th of a millimeter. Yes. And then the hole, which is controlling the, the eccentric part, the throw of this is within 4/100th of a millimeter. So the smallest is at the moment 2.47 and the largest is 2.51. Yeah. That's actually, well, that's okay. I believe this is doable. This means that there should be like a play in the thing that is attached to these, something like 2/100th of a millimeter. Then it won't bind. And I think that's acceptable. And yeah, and synchronization of the eccentric part and the gear teeth, it's perfect. I made a few measurements with this. So all in all, using arbors is highly recommended. I didn't realize how much this makes your living easier. Oh yeah, well, this eccentric arbor I never can use again. This is, and it is destroying nuts. Nut destroyer. But nevertheless, this one worked also very well. So, but the one that is concentric, I probably will use it again. It's quite common size, 10 millimeters. And you can screw in part into that one quite easily. Okay. So, well, in the next episode of Finno-Ugric Machining we are going to go further with these things. We are going to start to make the base that all these go into. It will be a thing with well, actually it is going to contain 2 large gears, and then the base is accommodating all this. It will be quite complex part, and it will be mostly milling this time. There will be some, well, my beloved Wohlhauter will probably serve me really well with this one. So, but this will be in the next episode of Finno-Ugric Machining. So, till then, see you!